I'm going to do a video on restoring a seat. Okay, so this is the seat of a GT550. Unfortunately, I can't spend too much time on this part of it, which is the tear down, because I need to get this for powder coating. I've got a load of stuff to go, but all I'm going to basically do is photograph it as normal, remove the parts. I'll try and find out if these are supposed to be plated. In fact, I probably will just plate them because they'll look a lot better. Took me a while to figure out if it was plastic or metal, because it sounded awfully like plastic. So I got that sorted. I mean, as you can see, it's not in great condition. You've got to be really careful to try and save as much as possible of the fittings. You'll actually get the seat cover no problem. But in terms of these small fittings, then you can struggle. I'll see how that's attached. See how this is attached here. Okay, not the worst, but definitely not the best. So I can't take this for powder coating. There's lots of repairs to do. You can see that. Yeah, that all has to be done. I'll put these little pieces back in as well. There's a crack there as well, I think. So yeah, I've got to do these repairs before I take it. Good news is that the actual seat pad's pretty good. I'll probably just reuse that. Okay, these things here grab the cover. I'm just looking at the condition of them. That one's no good. It's okay. That one needs a repair. That one's well gone. Yeah. All this side's really quite rotten. There's a fracture here. So this is going to go for powder coating. So I'm not overly concerned about removing this rust. I need to remove rust though, obviously, to see condition, and I'll have to remove rust to do the actual weld repair. But at the moment, what I'll do is to make a piece to weld onto this section here. So if you're going to weld onto it, you need to weld onto good material. In fact, I'll make it longer than that. Right, this you can see is quite heavily finned. That piece has fallen off. So it's pointless welding onto it. So what I'll do is I'll just crop the edge off and then weld a new piece on. So when you weld a new piece on, you want to be 100% weld, so you can't get any moisture go in between the two materials. If you're going to do a large piece, say I have done this as well. I had one that was fractured completely across. Right, so I had to make a complete piece. When you do that, you mould it in, right, and then don't just weld the edges, okay, because it's not bonded to the material. Right, the best thing to do then is to, fundamentally, if you imagine like this, so you drill holes in it, right, like little windows, and you weld through the window into the metal below. Okay, and that really does tie it into the piece. Obviously you wouldn't do it where you could see it. You wouldn't do it on this side. You'd actually do it on the other side, because you don't want to see that, obviously. So you'd weld the piece on this side. Just like when I come to do this, I'll be welding it on this side. I'll be welding it on this side. So yeah, I'll go make some pieces up. So this is the material I'll use. It's mild steel, it's bright mild steel. It's probably 0.8mm, something like that. It's very similar to the original metal, maybe a little bit thicker. But this is all I have. I think I do have some other material, but I'd imagine it's probably some more sheets of this. So I'll measure up a strip and just cut a strip. I'm just going to rough cut it first of all, and then I'll start to shape it when I actually offer it up. So the thing's curved, so you have to allow a bit extra so you can get the entire curve in. Okay, so I've made about 2 inches anyway. You can see that this is actually raised up, so I'm going to have to push this down this way. So. Got to somehow figure out how to get these things back in. Anybody got any ideas? Okay, let me have a go at that. I'll be honest with you, I haven't got a clue how to do that. But we'll give it a bash. Give it a bash. We'll give it a go. So I'm going to have a try at cutting those little triangle things out using a chisel. Right, so first of all I'm going to have to sharpen the chisel, and most of you will know this, but you don't sharpen a chisel on a grinding wheel. Don't do it. Okay, I mean you may remove bulk material if it's really blunted, but the way to sharpen a chisel is with a file. A file is harder than the chisel, and with a file you're not going to overheat the tip, because if you blew the tip, so because you leave it on the grinding wheel too long, you've knackered it. Okay, and you'll have to grind it right the way back to get rid of the blue. Okay, I'll be honest with you, that was so easy. It's really simple. I've got a deburrer. I'll get the and shaping that one up a bit. I'll get rid of some of these sharp edges, but yeah, really easy. Surprised me. So we'll replace those. So now what I have to do is get the shape back in. When I went to fit the piece I made, I found out the corrosion was too much. There was no good material to weld onto, so I've gone a bit further. Probably do with going a bit further there as well. Yeah. So I've gone a bit further, so I've made a longer piece, which is here. So this is going to go on here. So I'm going to weld it on. So I've got a few different ways I can weld it. I have two different MIGs. I've got quite a large MIG, which is got 0.8 wire in it. The problem with that one is that it's going to put too much heat into this. I'll just get burned through all the time. So instead I'm going to use my old smaller MIG. The smaller MIG is an old snap-on one I've owned for about 30 something years. The side casing's missing off it because I had a senior moment where I was clearing out and I found the side piece and thought, oh, I got rid of that years ago, and I threw it out, and then found the welding set, so that was pretty stupid of me. But yeah, so the difference between the MIG and the larger set, one is that the MIG can run off a 13 amp wall socket, which is obviously really convenient. The bigger one that you need, I think it's 15 or 16 amps, so you need to have a new cable run. The other thing is duty cycle, and what that is about how long you can continuously use it. Now the smaller MIG, you can use it all day. The snap-on MIG, you can just use it all day and it just continuously puts out the same current. It's really easy to use. The bigger one has got a smaller duty cycle, but you can put a lot more heat in it, so you can get much better penetration on thicker metal. But the duty cycle, when I've used it for more than about 2 hours, it'll start to trip on temperature. I've got a stick welder as well on manual metal arc MMA. That's got the worst duty cycle of the lot. It's a really cheap non-turbo, so it's not fan cooled, so as you're welding the internal resistance builds and the current drops off, so it's a real pain to use. Its duty cycle is probably at the most 30-40 minutes, but I do very little stick welding, very little, so it's good enough. It's okay for me. And the last method I've got is oxyacetylene, so I can either use directly use mild steel onto it, which I'm not going to do. I also can braze and silver solder. I'm going to avoid brazing because it doesn't look great, and the plan is to weld and then grind back, and we'll see how we get on. So this is me snap-on MIG. I've had this for over 30 years now. The side cover's missing because I threw it away by accident. I had a senior moment. I found the cover and I thought, oh, I got rid of that years ago, and chucked it away, and then found the MIG. So yeah, as I said, the duty cycle on this is much superior to the other set, although it's a lower current. It's 130 amp max. The other one's 150 amp. It's a gas type, so it uses a CO2 argon mix, which is great. It's just a mild steel, 0.6 mil, I think it is. A wire, and it just welds all day. You know, you get no drop off in performance. Its duty cycle is really excellent. When we compare that to a mess, this set over here, which is, I have 0.8 wire on this. It's gasless, so the wire has the flux in it. It's fine, yeah, especially for, you know, there's all these frames and that, the workbench and everything and other stuff I've talked about have all been welded using. Yeah, these are me 2 welding helmets. I've got a third one which has just got a normal screen in it. But we've got, this is the expensive one, this is a cheap one. Difference between the two is to do with latency of the auto dimming. So both these are auto dimming, both solar powered. And what I mean by that is that when you first look through them in a clear view, so you can see what you're welding, as soon as the arc strikes, it dims. Now this one will dim slightly quicker than this one. We're talking about milliseconds, but it is enough. So if you are gonna buy these, make sure you check the latency and go for the better one. Okay, which is this one. I can't remember what the figures are, but they are different. Okay, I bought this one just as a backup in case this one suddenly breaks on me, and I can still carry on working. But I've never used it to date. This has always been reliable. This knob here adjusts how dark the screen dims to. With the welding I do with MIG, you really don't want it to go too dark, otherwise you just can't see what you're welding. The arc is just not bright enough. When you're doing MMA, especially when if you're using 4 or 5 millimeter rods, you'll really need this turned up. On the inside we've got a couple of adjustments. One is sensitivity, and I don't have this very sensitive. As you can see, I've actually got it wound back a bit. I probably should turn it up a bit more, but it seems to work for me. The other one is setting it for either TIG, MMA, mag, metal and gas. Metal, I don't know what mag is. MIG, which is metal and air gas, and TIG. And then you got the other setting, which is TIG. I don't really understand that. I don't know what the difference is, I'll be honest with you. But that's what it is. So TIG is tungsten and air gas. I'm not sure why you can AC and DC TIG. Like you want an AC TIG on things like stainless steel and things like that, because it stirs a molten pool up, whereas you normally DC TIG. So, but I don't know why that is. But I've had it for years. This thing, years and years and years, and it's always set at that setting. This one, I've never really looked at this one. That on the sides will be dimness again, no doubt. No indication which way helps. Look on the inside. Yeah, we've got sensitivity, which is, instead of being that knob, it's low, medium, high, and delay time. So that is the latency. It's on short, and why you wouldn't have it on anything other than short, I don't know. Sensitivity is low, so very similar settings to that, to this one. Right, let's get the thing welded. So to weld this thing, I need to get this rust off and paint off. Don't weld onto rust and paint. Welding, as you know, professional welders will tell you, is all about surface preparation. If your surface preparations ain't right, you're not going to get it good. I also need to straighten this as well, obviously. So when I've been cutting it off, it's moved a bit. So I'll straighten that first, de-rust it, and then start the welding. I'll clamp it here and there, and then yeah, crack on. What I'll do is first attach it here, and then just stitch weld it along as I form it round until I get to the end here, right, and then I'll run a full weld along, right, turn it over and then start forming it into shape. So that's it, stitch welded in place. I'm just checking the fit. You can, with the little tiny stitch welds, you can just grind them off and then reposition it, but I'll be honest with you, I don't think it's far off. The metal's got to be cut back here obviously, but I think I'm quite happy. I think I'll go for the full weld now. So what I'll do is I'll full weld it along. You've got to be really careful, like, because the metal is thin. Even originally it's quite thin, so if you get too much heat you'll just burn it away. So really good control of your melting pool temperature. If necessary, weld here, weld here, weld here, weld here. There are advantages in doing that as well, because if I just start here and weld across, you end up with a buckle like that. So I will be jumping around, but you should jump around anyway, just so you don't end up with too much heat and end up with burn through. But yeah, let's crack on. That's it welded. So next thing to do is I've just got a little bit of neatening up on this side here when it cools down. Then what I do is, again, just neaten these edges off. What I need to do is end up with probably about a 10mm proud lip all the way along. So I'll just crop these edges off with a pair of tin snips, and then I'll use the oxyacetylene just to heat it up and just tap it over to meet the original shape. If I don't use oxyacetylene, I'll end up creasing the material. And you'll really struggle to get it back. There are some, as you can see, it's not entirely square, but it's not far off. I'm quite happy with that. So there is some thinning on the material here as well, as you can see there. It's funny, it's just one side seems to have been affected. That's the welding on the top side finished now. So the piece is in. This bit of bad welding here is because my gas ran out, unfortunately, because I left the gas valve leaks, so unless you unscrew it, unfortunately I'll lose my gas. So I'm not it's really quite thin in places. So what I'm actually going to do is I'm actually going to grind back some of this rolled edges. Now you need a rolled edge, right, because it's that gives us the stiffness to the plate, otherwise the plate's flexible. So I will put a rolled edge in, but what I'll do is I'll just take the sharp bits off, because that's just going to cut the seat material anyway, right, and then I'll just put a very fine rolled edge on all the way around, show my finger, and then I'm going to use a plastic edging, trim edging strip. And that has the advantage as well, as it creates a nice soft edge for the new seat material to roll over. So yeah, that's next. So all this rust, that's all going to come off with powder coating. I'm just gonna, what I'll do now is I'll do these rolled edges. I'll clean this up, and then send it for powder coating.